Degrees of freedom. Same example I am taking. Same up to 50,000, up to 5,000 to 10,000, 5,000 to 10,000. Here, this one 20,000 to 30,000. Now, out of this 200, 150. Out of these 250, this is 100, this is 100. Right. Now, expected, we know how to calculate. Now, actual, that is the observed. Observe. Now, how many people can be here in this category? It can be 50, it can be 60, right? That is this column I am telling. Okay, up to 5,000, up to 20,000. This can be 50, or this can be 60, or this can be 70, or it can be 80, or it can be 90. Okay. So it can be anything. It can be anything. There is a freedom to have anything. There is a freedom to have anything. Now, any value can come. Freedom. I have a freedom. Now, let us assume that I put 8. I put 8. I have a freedom. I can put 60, 65, 70, anything. But I put 8. I have freedom. 80. Right. Okay. That's cell. I have freedom. Okay. I put 80. Now, any value can come, but I put 80. Now, what is the value can come here? Whether I have any freedom? No, I do not have any freedom. I can put only 70. No freedom. Because total is 150. Total is 150. Right. So, I can put only 70, no freedom. Now, let us come here. Already I have put 80 here. Now, here, I do not have any freedom. I have to put only 20. So, no freedom. I have put 20 because total 100. So, here also, I do not have any freedom. I have to put only 30. So, out of these 4 cells, I have only one freedom here. Okay. So, my freedom is only 1. Which means, what extent I have freedom? Degrees of freedom. I have only 1. Now, what is the formula for degrees of freedom? Row minus 1 into column minus 1. Row is 2. Here I have 2 rows. 2 minus 1 into column minus 1, 2 column, 2 minus 1. So, which means 1 into 1, which is equal to 1. So, which means I have only 1 freedom. I have only 1 freedom. In our case, what is the degrees of freedom? Let me go to our case. Okay. Okay. So now here, first cell I can put anything. This one I can put anything. This one I can put anything. This one I can put anything. But last one I cannot put anything. Like that I can put anything. Last row I cannot put anything. That is why if I have 5 rows, I can put anything on the 4 rows. Last row I cannot put, or minus 1. Right. In the column, okay. So this, sorry, I have explained column. Now let us go to the column. Now this I can come anything, this I can come anything, this I can come anything, this I can come. But this one I cannot put anything. According to, because total I have 1, 2, 3. Remaining only I can put. So which means this column I can put anything, this column I can put anything, this column, but last column I cannot put anything. So that is why column minus 1. So row minus 1 into column minus 1. Here 5 row, 5 minus 1, 4 into 5 minus 1, 4, 4 into 4. My degrees of freedom is 16. Okay, now, so anyway, if you have only one column, you can serve anything. N minus, if you have 500, this one frequency, n minus 1 is the degrees of freedom. Only one column, only one. N minus 1 number of this one. Last one you cannot put any. That is the degrees of freedom. Right. So that is the degrees of freedom. All right. Very good. Okay. So somebody has asked me, what is the okay. So now I have taken one more example, right? I have taken one more example, right? Okay. That is I have taken motives and perception cluster. Okay. Here three column, this one. Okay. Okay. So now, okay, I have something more to tell, but even that. So this is the example I have taken, which means perception. I have three perception: high positive, positive, negative. Saving motive, highly motivated, weakly motivated, self-centered, which means there are three motives. Okay, family-oriented motive, self-motive. So if they have more, both, that is called highly motivated. If they have less in both, they call weakly. If they have more in self-centered, so they call it self-centered. Okay, three. So two variable, perception and motives, both are categorical, three category. Okay. Now this one, this is the cross tabulation. Now, okay, first cross tabulation I will get a high square test. Now, from this high square test, I have to see the significant value. My significant value is 0.001, which is less than 0.05, which means null hypothesis is rejected. So no association is rejected, which means there is an association between saving motives and the perception about the saving instrument. Right. Now, since I have stated that there is a association, I should not stop here. I should go for a post hoc. Now, this is a column percentage post hoc. Now, this column is more than this one. So, highly motivated associated with high positive. Now, this one weakly motivated. You can see here is more. So, which means weakly motivated is associated with negative. Now, highly motivated, high positive, weakly motivated with negative. Self-centered, okay, self-centered with, now see the percentage, self-centered with the 43, self-centered with the positive. Now, let me tell again, from the column percentage, I have identified that highly motivated associated with the high positive, weakly motivated associated with negative, and self-centered associated with the positive. Now, adjusted residual. Adjusted residual, now we can see here. Now, which one is more I am searching? Now, here, 3.4. Now, highly motivated associated with highly positive, 3.7. Right, that is over. Now, next one is, this is associated over. Now, weakly motivated, here 2.4. Next, these two I am looking at. Weakly motivated is associated with 2.4. Now, you have to see that this one you have to ignore, because we have concluded that highly positive associated with highly motive, which means that row and that column you should ignore. Remaining 4 only you have to see. So, remaining 4, weakly motivated is associated with negative. Then self-centered is associated with positive. So it is going along with the same with column percentage. Now, correspondent analysis. All right. So now, correspondent analysis result. Now, high positive, highly motivated. Self-centered, positive. Weekly, same result. Same. This will give us same result. Very good. Now, strength of association. Here, okay. Now, having stated there is an association, we should not stop. We should produce more interesting results. Okay, that is why we need to go for the another one. Here, pi grammacy, pi and grammacy, right? So here I have not written pi grammacy full this one. Now I will go here. Okay, now let me go here. Okay, that is the strength of association, thickness of association, right? Otherwise, even statistically, they will call it as effect size. Effect size. Okay, effect size. Now it is a rule of thumb. Different people will give different rule. I have taken this one from one book. The Naresh Malhotra has given a different this one. Same thing, little different value they will do. He will be interested to have up to 6. That is also given in the this one. Now, whatever I have given the documents, if you see that I have given what is available in the Naresh Malhotra, that page output also I have given there. You can see. Okay, so now value is 0.1 is small, 0.3 is medium, 0.5 is large. Now look at the pi, 0.48. Now, whether I can say large, whether I can say medium, because it is between 3 and 5. What I can say, if it is above 4, something like that, then I can say medium or less than 4. But it is more than 4, it is approximately near to 5. Then what I can say? I can say there is a large effect, which means strength of association is very, very strong. I can tell like that. Now, let me look at the other one. Normally, pi is used for 2 by 2 matrix, but even then you can use it. Okay, but Kramer's-V is more appropriate. Now, Kramer's-V. Now we know degrees of freedom. Now here, degrees of freedom equal to minimum of r minus 1, comma c minus minimum of. So here now in this case, first case, 5 category row, 5 category income, 5 category sales. So 5 minus 1 4, 5 minus 1 4, 4 comma 4, minimum of 4 comma 4, which is 4. Now we have to look at now 0.05 small, 0.15 medium, 0.25 large. Okay. Now these are all the values given hypothetical. That is the rule of thumb values given by the authors. Now I am looking at my result. It is 0.241. Where to put 0.15 is medium, 0.25 is large. Where I can put it is 0.241, which is approximately nearer to large 2.5. So I can say there is a large effect. There is a large effect, right? So this is what the high square is over with this one. We need to see significant value, right? So whenever we are writing the significant value, we have to write the calculated value, degrees of freedom, and the significant value. That whenever we report in a thesis, we have to report those 3 values. For example, what we have to report? Now I will tell. Okay. How I have reported. Now see, I have reported calculated value, and degrees of freedom and the significant value. Like that, you have to report. Okay, all the three. Okay. Okay. Now, are you clear? Shall I go for some more thing? Hello.
Yes, sir.
Ah,
Yes, sir. Yes, sir. Thank you so much. Yeah.
okay. Very
Thank
good.
you,
Very
sir.
good. Now the matter is not over, madam. Okay. Now, after having seen the strength of freedom, I have to go for one more thing. What is one more thing? Normally, we have to use chi square only when you have 3 by 3. Okay, we should not use, that is the one variable we are having three options. Another variable also three category. In every variable three categories you should have. But if you have 2 by 2 matrix, now what happens? Our statistic people, statistician people, researcher are not simply sitting. They want to contribute something, no. So what they are doing, whatever problem they have reported, for each problem they are giving the solution. That becomes their own contribution. Now when somebody said the only 2 by 2 matrix we should not use, then another gentleman he said no, we can use but if you use a Yates correction, we can use Yates correction and we can use for 2 by 2 matrix. Okay, 2 by 2 matrix, right? Okay. So now I have here also male, female. I have only two category. Okay. Here also I have only two category. I have two category only. Okay. So now this idea is, what is this idea? Okay, whether sender, whether they are purchased from organized retail store or not. Okay, so we are asking the people, organized retail mode of purchase, organized yes or no, female or male. Okay, like that. Okay, so now analyze. You know what to do. You know chi-square how to analyze descriptive statistics, cross tab. I'm putting center here. Okay. Now I am not touching. Let me use only chi square. Okay, let me use only chi square. I am not touching anything. I am not touching anything. Right, very good. Now, if you see, okay, I am getting a two table. I am getting a two table, right? So those two tables are presented in the PowerPoint. So this is the frequency table. This is the observed value, 39. 118 is the observed value. Now you can find out calculated value. You need not go to that expected value. Go in that column, okay, then clicking expected usage. Now you can find out 177, okay, into 209 divided by 582. Otherwise, 177 divided by 582 into 209. We can use and we can find out expected. You know everything, right? Very good. Now, this output also I brought it. Now, here, if you are seeing the first output, they might have in the earlier output, you might have seen Pearson chi-square, this, you might have seen likelihood ratio, you might have seen linear by linear, you might have seen number of valid cases. These are all you might have seen. But what is new here is continuity correction. This is the new one. When you will get, whenever you use 2 by 2 matrix, then you will get this value. Now see here B, you can see here B, computer only for 2 by 2 table. Okay, now whenever you use I-square for 2 by 2, you should not use this Pearson chi-square value. You have to use corrected chi-square value. This is called corrected high. It is not 0.734. It is 0.583, and the significant value is not 0.392. It is 0.446, which means there is null hypothesis accepted, which means there is no association. Then we cannot say male they prefer organized retail, female they do not prefer organized retail, because there is no association. The organized retail, yes, no. Gender, no. No association. Which means we cannot tell whether female prefer yes, no, male prefer yes. Like that we cannot tell. No association. Alright. Now very simple. For all 2 by 2 matrix, you have to take this continuity corrected value. This is called corrected chi-square value. This is what you have to use for your interpretation. Very good. Okay. So we know the correct. Okay. Now next one. Next one. Right. Very good. Now see. You see this output. Okay, whenever we have performed the first chi-square test, right, we got this result. Pearson chi-square 128, 16, significant value, likelihood ratio 120, 16, fine, all these things you got it. Yes or no? Yes or no? Yes. Right. Very good. Now, in the bottom, we have something. We have something. Here, A. What is this A? It says 6 cells, that is out of 25 cells, 6 cells, that is 25% of the cells have expected count less than 5. This is the warning message. This is the warning it is giving. Array gentlemen, you cannot have the expected count less than 5. Whenever you use a chi-square, your expected value should not be less than 5. But in your case, there are 6 cells have expected count less than 5. Okay. Now let us see whether it is true or not. Now we have seen the output by showing expected and observed. Now this one. Do you remember this one? If you click that expected will come. Right. Now this is the count, this is the expected. This also we already got it, I have copied. Now see expected count. See, it is 4.71, less than 5. Here, 3.9, less than 5. Here, 2.1. Right, here, which means 1, 2, 3, 4 cases. Now let us look at this one. Here, 5. Right. So now this one 6. This one no problem, this one no problem. Which means in this column 4 cells have expected count less than 5. Here 2 cells. So 6 cells have expected count less than 5. That is what it is telling. That is what it is telling. Okay. Which means you should not use. There is a warning. It is not error, it is a warning. Be careful in interpreting this chi-square value. A. We are getting a chi-square value, but that should be carefully treated. Okay. Because there is a warning. Now what to do? What to do? Now, if you look at this table closely, we can see this column 4 cells, this column 2 cells. All right, creating a trouble. Now what you can do is, you can combine those two columns. Now, instead of having two columns like this, two category, we have put 15,000 to 20,000 category, 20,000 and above category. Let us not put that. We will say above 15,000. Then what we will say? If you put above 15,000, this also will be, this both will be combined. Both will be combined. This will be combined. So it will become 8. This will become 20. This will become 15. So your problem will be solved, right? So your problem will be solved, right? Okay. Now clear? Any questions, sir? Any question?
No, sir. Clear, sir.
Very good. Now,
But can you explain once again why we want to combine?
okay, now, sir. Now this output says this calculated value. This is what calculated value, main value. This value calculated with the 6 cells having expected count less than 5. I will come Y. I will come Y. Okay. Now, but it says it is a warning. Now I am looking at the expected cell values. Now see the expected count value. Here 4.7. Here 3.92. Here 2.13. Here 4. Which means in this column, 4 cells having expected count less than 5. Let us look at this one. Here more than 5, more than 5, more than 5. But here 4 less than 5. Here 3.9 less than 5. So here 2, here 4. Which means totally 6 cells have less than 5. Right? So I should not have that. To avoid that, I want to use chi-square. To avoid that, what I am doing, why I should have two different category, like above 15,000 and to 20,000, 15,000 to 20,000, 20,000 and above. I have two categories. Instead, what I am going to say, I am going to put up to 50,000 category, 50,000 to 10,000, 10,000 to 50,000. The last category will be 15,000 and above. Like that I am going to say. Then what will happen? All the people who are in the above 20,000 also will be in the above 15,000. Combined. Right? So automatically your observed value will be more. Automatically your expected value will be more. That is the reason we are combining. Okay. Okay. Very good. Now, see, now, sir, I have done all these things, sir. Okay, sir. Okay. Now, for example, we got a. Now, see here, the second example, 0 cells. Because we have 3 categories, right? 3 categories. So 0 cells have expected count, right? No problem. But here we have that is the first example, we have that problem. Okay, so we have this problem. Okay, now on. Wait. Now look at the formula. Now what is the formula? Now what is the formula for the chi-square value? Now, if you look at the chi-square value, this calculated value, right? So it is stating that calculated value 128.63 A. That for that A only it is reporting expected value. Now, what we are doing is we are calculating the calculated value. We are looking at the table, right? For 5% level, we say that okay 26.29. Now, if the calculated value is more than 26, my significant value will be less than 0.05. Okay, that is when calculated value is more. Calculated value is more than 120 is 29. If it is 30, 40 like that, right? Then my significant value will be less than 0.05. I will say there is an association. Now see this formula. This formula is calculated. Now please understand, when the calculated is more and more association. Simple. Okay, more and more association. Now, with the calculated value increase, look at the E. Where is E? Where is E? E in the bottom. Yes or no? That is why when the calculated E value is less than 5, unnecessarily my chi-square value will be inflated. Then you will say there will be more and more association. To avoid that, they say at least if it is less than 5, please do not use. That is what they are. So now expected count should be more than 5. Okay. Now I have one question. Some people, okay, they will say you need to have sample size of 50. Only you can use this chi-square sir. Another, okay, the expected value should be greater than 5, like that, right? Like that. This is one more. For example, in the assumption they will tell your sample size should be more than 50. Can you tell what is the reason? Why 50? Not why 50, exactly not 50. Okay, a minimum 50 you need to have why. Why? Okay, because we say that earlier we can use chi-square only when you have 3 by 3 matrix and more. Right? 3 by 3 matrix. Roughly, I am telling, roughly 3 by 3 matrix. Now, if you have 3 by 3 matrix, then you will have 9 cells. Then we are telling one more. Hey, you need to have the expected value of 5. Right? The expected value depends upon the observed value, because that is calculated based on the observed. Now 9 cells. If you put each cell 5, then 9 into 5, 45. Minimum you need to have 45. So that is why some magic figure they are telling your okay. So sample size should be more than 50. Then only your answer will be reliable. See, it is a system. Whatever you put, it will do. Okay, but okay. So since these two are there, 3 by 3 matrix, 5. So 3 by 3, 9. 9 into 5, 45. Then only your calculated value will be reliable. Otherwise, it will be inflated one. It will be inflated one because of your problem. That is not reliable. Okay, so that is not reliable, right? Okay, so now I think we will stop here. Okay, so there is a 5% level. Why it is here that I will tell next class, right? Okay.